Welcome to EDU World Space.
Okay, in this problem, we're taking a look at car rearview mirrors. The first thing we need to ask is qualitative. We need to answer the question, if it's the case that objects appear to be smaller in a car's rearview mirrors, is that mirror concave or convex? Of course, it's going to have to be convex because only convex mirrors can produce images that are upright and smaller. So we can do that qualitatively just by knowing what the differences are between concave and convex mirrors. So the very first answer is simply convex. We know this because the images, just to recap, are upright, and they're always smaller than the object. So with that said, if we have some information about the distance of the object, in this case, car is 18 meters away, and we know that the images are a lot smaller than the object, and it's exactly a third smaller, we can find the radius of curvature for these convex mirrors. To do that, we're going to use a couple different equations. We'll use not the definition of magnification, but a convenient way to calculate it using the ratio of distances for the image and object, respectively. We use this very often. We also use the ideal lens equation, 1 over d naught plus 1 over di equals 1 over f, where f is the focal length of the mirror. And lastly, we can use the fact that the radius of curvature for a mirror is always 2 times its focal length. Using these three results and the information we have, we can solve for r. So to start us off, we can reorganize the magnification equation to give us di equals negative m d naught. We can then reorganize the focal length, the lens equation, to give us f equals d naught di over d naught m minus 1. Or rather, let's write this a little bit less simple. What we should do is d naught minus m d naught, just to be more clear where that came from in the algebra. We can simplify this a little bit more by combining with the result for magnification, di equals negative m d naught. So we can do one more step to get this a little bit simpler. M d naught over m minus 1. We know m and we know d naught, so we can get a numerical result for f of let's actually put the numbers in. 0.33 times 18 over 0.33 minus 1, which will give us negative 8.866 centimeters. That's the focal length. To get the radius of curvature, we simply multiply this by 2. R is equal to 2f, which is also equal to negative 17.7 meters. So the radius of curvature for this mirror is quite large. And you can verify this yourself. If you look at your rear view mirror, you're not going to see a massive amount of curvature. And this confirms that. So that's it. We combined 3 equations for magnification, for lenses, and for radius curvature. Combined them, used the information we knew, and we found the radius curvature. And that's it.